Good morning, ma'am. My name is Tunishwa, son of Madhivanan. My metric number is 10DEE20F2044. So now I'm going to present presentation 1, which is the cost of DEE20023 semiconductor devices. So now I'm going to start to present question 1. So the question 1 is, by using a suitable diagram, explain how an n-type semiconductor can be produced. So the diagram is this round, and this is arsenic and silicons. Okay, so now here the points of the semiconductor. The n-type semiconductor will form. How the n-type semiconductor formation of n-type semiconductor. So I'm going to explain about it. So n-type semiconductor will be formed when pure semiconductor is doped with pentavalent impurities, which means 5 valent electron. When subtracting a silicon atom in the crystalline lattice, four of the valence electron of the arsenic form covalent bond with the high neighboring silicon atom. Both the fit one remain weak bonded at room temperature. All the fit electrons are liberated, can move around the silicon crystal, and can carry a current. Moreover, the electrons are the majority carries, and the holes are the minority carries. It is because the 5 electron atom have an extra electron to donate, which called donor atoms. Finally, the extra electron are called n-type semiconductor because it is negatively charged. And now I'm going to present question 2, which is discuss the difference between a full wave center tap rectifier and a full wave bridge rectifier. Here, there are different rectifier uh, two diagram, which is one is full wave center tap rectifier and second is full wave bridge rectifier. So for full wave center tap rectifier, two diodes are used on for each half of the cycle, and moreover two diodes are connected to a center tap transformer, and the output is twice that of the center tap circuit for the sum secondary voltage. And for full wave bridge rectifier, the four diodes are connected to a transformer and not in the not as a center tap. Moreover, the internal voltage is drop is more than full wave center tap rectifier. Moreover, I'm going to share some of the things about the full wave center tap rectifier. The center tap full wave rectifier uses as a center tap transformer to convert the input AC voltage into output DC voltage. And when AC voltage is applied, the secondary winding of the center tap transformer divide this input AC voltage into two parts. One is positive and negative. And next, for full wave bridge rectifier. This type of a single phase rectifier use four individual rectifying diodes connected in a closed loop bridge configuration to produce the desired output. The main advantage of this bridge circuit is that it does not require a special center tap transformer, thereby reducing its size and cost. The single secondary winding is connected to one side of the diode bridge network. And finally, the last question was question 3, which is, with the aid of diagram and output waveform, discuss the difference between amplifier class A, B, and AB amplifiers. So here I show the diagram of class A amplifier, which means 0 to 360 degree. is one full sine wave. And for class B amplifier is the half sine wave, which means 180 to 360 Celsius. And for class AB amplifier, it is 100 in between of 180 to 360, which means like in between of 180 degree to 360 degrees. It's in between that. So yes, the diagram, and now I'm going to share the difference. So just now I already tell that conduction angle of amplifier A is 360 compared to amplifier B is 180 degree, and for amplifier A and B is 180 degree to 360 degree. Second difference was position of the Q point, which means for amplifier A, the center point of the load line, and for amplifier B is exactly on the x-axis, and for amplifier AB in between the x-axis and the center load line. So, and the next difference was signal distortion, which means for amplifier A, non-correctly biased, and for amplifier B, at the axis of crossover point, and amplifiers AB was small amounts. And finally, they are and finally the amplifier was have a different application, which means for amplifier A, they are used for voltage amplifier and current amplifier. And for amplifier B, they are used for power amplifier. And lastly, amplifier AB was used for transmitter and oscillator. So this is the difference between amplifier A, B, and amplifier AB. So that's all from me for presentation one. Thank you, man.